So we talk about convergence, but do we really know what that means mathematically? Do we know why we can say that something converges to a value? And that's what the last part of 9.1 is about. How do we define convergence? And it's defined by this statement here. We're going to let L be a real number. And we can say that the limit of a sequence is L if, for each epsilon greater than 0, there exists an M such that the difference between our sequence term and L is less than epsilon for all n values greater than that M. When this limit exists, like we saw in the first part of 9.1, the sequence converges to L. So what this essentially means is somebody can come along and say, okay, I want you to be within 0.001 of this limit you're claiming. And you can come back and say, okay, here's how many terms will get me within that close. And then they could say, I want you within 0.00001. And we can come back and say, okay, here's the term number where we're within that close to this epsilon value. So we're going to prove that 5 minus 1 over n squared converges to 5. So we want the difference of 5 minus 1 over n squared and 5 to be less than epsilon. This is our sequence rule, less than 5. And what we're left with is 1 over n squared is less than epsilon. I can do away with the absolute values when I take this minus n squared. That makes it positive. And then I can rearrange this and say that 1 over epsilon is less than n squared. So n we want to be bigger than the square root of 1 over epsilon. So for our proof, we're going to choose that m is the square root of 1 over epsilon. And if somebody comes along and says, you need to be this close to the limit, you can tell them how many terms you'll need at least. Now this isn't the actual proof. This is just setting up our proof. So what we're going to do is we're going to let epsilon be bigger than 0 and m equal this thing that we found on the left-hand side. Then for all n bigger than that m, what that means is that n has to be greater than 1 over the square root of epsilon. So n squared has to be greater than 1 over epsilon, and epsilon would have to be greater than 1 over n squared. And since that's true, then epsilon has to be greater than the absolute value of 1 over n squared. And if that's true, then 5 minus 1 over n squared minus 5 has to be less than epsilon. So for n's greater than that m value that I found, that thing is true. The absolute value of a sub n minus 5 is less than epsilon. And that's the end of our proof. Sort of what we do is we set up what we want, what we'll need n to be, and then we work backwards to what we want. So I sort of go one direction, then the actual proof is just working the opposite way. You've probably worked problems in reverse before, where you look at the back of the book, you see what the answer is, then you reverse engineer to get the steps you need. That's exactly what we're doing here. We know what we want to end up with. We have to reverse engineer what we need to start with. That is, what value do we need for m? Or what equation do we need for m? So another one, we want to prove 1 over n squared converges to 0. Another way to say that is that the limit as n goes to infinity of 1 over n squared equals 0. So now we set up our proof. We do our setup part. We want the absolute value of 1 over n squared minus the limit to be less than epsilon. Therefore, we want epsilon or we want n to be bigger than 1 over the square root of epsilon. So we're going to choose m to be that 1 over square root epsilon again. And then it's time to do our proof. Let epsilon be bigger than 0. And choose m to be equal to 1 over the square root of epsilon. For n bigger than m, that would imply that n has to be bigger than 1 over the square root of epsilon. So here's where we're working backwards up this. So epsilon has to be greater than 1 over n squared. Which means that it also has to be greater than the absolute value of 1 over n squared. Which implies that 1 over n squared minus 0 is less than epsilon. So to conclude this, we say when n is bigger than m, the absolute value of 1 over n squared minus 0, the convergent value, the limit, is less than epsilon. And we're done with that proof. The homework that you need to do is to prove these two limits.